So many quadratic equations cannot be solved by factoring. And because completing the square is so tedious, we almost always turn to the quadratic formula to solve a quadratic equation. Besides, the quadratic formula is the result of a pattern involved when solving by completing the square. And if you did the proof for me in a bonus question, it would follow. I don't think I'm going to go ahead and do the proof on the video. I'm going to leave that for your work. But what we discovered was that any quadratic equation could be solved by taking the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So remember that I mentioned that the a, b, and c values are, the a values are the numbers that are in front of the x squared term. The b value is the number that's in front of x. And the c value is the constant. And if you get the terms on the left side or the right side of the equal sign and 0 on the other side, then you can use those a, b, and c values in this formula and solve. So let's go ahead and do that. So you see this minus 3? When I was completing the square, I wanted it over there, but now I don't want it over there. I want the 3 to be on the left side as a positive 3 and 0 on the right side. So now from this, I can see that my a value, the number that's in front of x squared, will be a 5. My b value is an 8. That's the number in front of x. And my c value is the constant 3. Then I'm going to put into this formula that says to take the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. All right, so b is 8. b is the number in front of x. I want the opposite of that, so I'll put a negative 8 here. Plus or minus. Whatever you do, the b value is always squared. So whether it's negative or not, would you just put a positive number in here, squared, minus 4 times my a value in this problem is a 5. So the number in front of the x squared term is a 5. 4 times a. My c is the constant. That's the 3. All divided by all over 2 times a. a is 5. That line's got to go underneath all of that numerator. I prefer now for you to find the value of what's under the radical. The 8 squared minus the 4 times 5 times 3. Seriously, just go ahead if you need to and take 8 squared minus 4 times 5 times 3 and get that number. That's called the discriminant. So I have a negative 8 plus or minus, and underneath the radical is a 4. 2 times 5 downstairs is 10. And I don't know if this looks familiar to you from completing the square, but I've got to take a negative 8 plus or minus the square root of 4, which is 2, all divided by 10, and I'll have my 2 answers for this problem. So a negative 8 plus 2 over 10 is a negative 6 over 10, which is a negative 3 over 5. And then a negative 8 minus 2 over 10 is a negative 10 over 10, which is a negative 1. So my 2 answers for this problem, x is equal to a negative 3/5 and x is equal to a negative 1. I want to take you to graphing. I'm just periodically going to do that. So y equals, the original problem was 5x squared plus 8x plus 3 though, because remember, I want y to equal 0. I want to see where the graph of this line crosses the x-axis. I saw that my answers were a negative 3/5 and a negative 1. So when I graph this, I should be fine because I'm expecting my answers right in here. Right in there. I could change my window a little bit to have it just, since my answers are a negative 1 and a negative 3/5, I could go from a negative 2 to 0 for x min and x max. And you know, I'm not going to go so small for y way down to a negative 10. I'm going to have it go down to a negative 2 and up to a positive 2. I picked 3, that's all right. And let's hit graph. And let's see where that crosses. Did you see this tick mark right here? That's a -1. And that spot right here, this is 0. So here's a -1. There's the -3/10. And I can find these by going second calc, or the trace key, and I can find the 0 of the function where y is equal to 0. I'm going to select a number 2. And it says, Pat, will you give me a left boundary? So there it is for me. That's to the left of that spot. I'm going to hit enter. Now it says, Pat, give me a right boundary. So I'm going to go below the x-axis. It looks like I am. And I'm going to hit enter and see how it's going to search right here between these arrowheads. And it says, do you want me to guess? And I hit enter again. And it takes me right to the solution. X is a -1 when y is equal to 0. Let's do this one right here. So second calc. I'm finding the 0 of the function. Where does it cross the x-axis, which is where y is equal to 0? It wants the left boundary. I'm going to go a little closer to the other solution, but under the x-axis, because here's the point I'm trying to find right there, and this is to the left of that. So I'm going to hit enter. A right boundary's got to be over here somewhere. So I got to get above the x-axis. Y's got to go positive. Watch your y value. Oh, good, it's already positive. There we go. That's good enough. Anywhere in there. Hit enter. It's going to search between these arrowheads to look for that spot. It's asking me if I want to guess, and I'm going to say yes by hitting enter. And I see that my x value is a -6/10, which is 3/5. So this is the fourth way to solve by graphing. So don't forget, we solved, I'm going to turn the page here, but I don't think I was ready to turn the page. We solved by factoring, by completing the square, by quadratic formula, and graphically. It looks as though I'm not going to be able to scroll this problem up very high, so I'm going to erase the work for this problem and do it up above. So I'm going to go ahead now and do number 2. And would you get ready by writing down that a is equal to 3 for number 2. A is equal to 3. It's the coefficient in front of the x squared term. B is equal to a -6. And C is equal to a -4. And so x would be found by taking the opposite of b. It's a -6. So I'm going to put a +6 here. Plus or minus b squared, which is a -6 squared, minus 4 times a. My a value is 3. My c value is a -4. All over 2 times a. And I desperately need you to find the value of the discriminant, the number under the radical, because I am going to start talking about how many solutions there are to a quadratic equation, and it's dependent with this number under the radical. So let's see, where can I do this? Not much space here. Let's see if I can try this. The -6 squared, I'm just going to type as 6 squared, because I know it's positive no matter what. Minus 4 times 3 times a -4. You don't need any parentheses here. It knows that this negative times this negative is going to be positive, so it knows this is 36, and this is 12 times 4, which is 12 times 4, which is 48, and 36 plus 48 is this 84. So I have 6 plus or minus the square root of 84 all over 6. Whatever you do, don't cancel those 6. The 6 belongs to the square root of 84 too. We have learned to simplify the square root of 84, and what I'm looking for is two numbers that multiply to be 84, where one of them is a perfect square, and I think 4 is the only number, because 4 times 21 is 84. So the square root of 4 is 2 times the square root of 21. So this problem can be reduced a little bit, because the square root of 84 is 2 times the square root of 21 all over this 6. You know, again, lots of ways to do it. You can just say that an even number goes into all of these. So you could say 2 factors out of the numerator, and you'd have 3 plus or minus 1 times the square root of 21. And the denominator would be 2 times 3, and those would cancel out. So you'd have 3 plus or minus the square root of 21 over 3. I could have done that by saying 2 goes into here once, 2 goes into here 3 times, 2 goes into there 3 times. And I have 3 plus or minus, 1 times the square root of 21 is just that 1 over 3. You can write it one other way. So you can write it as 3 over 3 plus or minus the square root of 21 over 3. You just got to be sure that that goes there. And don't be trying to divide that and calling it 7, because this is not the number 21. It's the square root of 21. And then you would be allowed to call that 3 over 3 1 plus or minus the square root of 21 over 3. I really only wish for you to get to this spot. I'm real happy if you reduce it to this point. Let's take a break and come back and use the quadratic formula a little bit more.